Wait. You know what? I wonder... What's the correct way to hold a bowl of soup? I mean, here's the thing, when you're holding a bowl of hot soup, you want to minimize the surface area that's actually touching the bowl, because the bowl is hot, and hot stuff generally hurts us when we touch it for too long. But at the same time, we don't want to touch it too little, because then, well, we'll lose control of the bowl. We'll either drop it, or we will spill the soup all over ourselves. So, what's the perfect amount? The answer to that is obvious. It's 3 points in space define a plane, and plane is what we're going for. Here's the thing, 1 point in space defines a point. 1 point defines it's a point that defines a... you get it. Point is zero-dimensional because it has no size. It's a mathematical point with size of infinitely small. 2 points define a line, which is one-dimensional, because we have one dimension, either right or left. 3 points define a plane, which gives us 2 dimensions to play with. 4 points define a space, like this one, right here. If you want to define a singular space, then you do need 4 points. This is actually really hard to visualize, considering that you have 3 dimensions to visualize 3 dimensions. But just trust me, 4 points define a space. Here's the question, why do you want to define a plane for a 3-dimensional ball? Wouldn't a space be better? Wouldn't 4 fingers be better? Well, it's because rotations. That's why. It is because of rotations and how lines and planes affect our rotations. Because you see, when you have a line, you could rotate like this. That's how you can rotate around a line. It's because of its dimensionality. But when you define a plane, you see it is different. When you hold it with your 3 fingers, alright, you create a plane. Now this plane cannot rotate this way, nor this way. These are the 2 dimensions we've defined. But it can very much rotate this way, which doesn't matter for us. This isn't spilling any soup. That's why a plane is also better than a line, because whilst with a plane you can choose almost any point on the sides and have correct rotation, with a line the only 2 points that would work would look like this. I think you get why a line is suboptimal. But there's an issue with this approach. You see, math is perfect, which is great. It allows us to simplify things, makes the calculation a lot more doable. But it also means that it kind of offsets with the reality. The reality cannot follow math exactly because the reality is not perfect. And your fingers aren't points. I'm sorry to spoil this, surprise, but they are really not. And if you're holding your ball with just 1 finger, you're not holding it with a point, you're holding it with hundreds of thousands of points. Or maybe millions of points. Or billions of points. Or maybe an infinite amount of points depending on how you count things. So we need a bit of a redefinition. We have to change our model to not hold the ball with 3 points, only 3 fingers. So these will be the places where the impact happens. Because you see, if you hold it with 3 fingers like this, you won't be able to hold it. How do we define the impact points? Well, same as objects when interacting with gravity. If you think about it, the Earth is not really a single object, it's many objects, many atoms even. If you are just counting atoms, well then it's crazy big amount of objects. But when we're calculating stuff, we usually count Earth as a single object, a single point of space with a given gravity. So we can do the same thing here, which means if our points are sufficiently spaced apart, then they become different impact places. But here's the thing, what's sufficiently spaced apart? Well, if we're doing just a quick model for holding up soup, then we would just give it a constant value, or a value relative to the size of the impact point and relative to the size of the soup bowl. But we're not doing it for the speed, we're doing it for the accuracy. Now we can change our definition to different impact points are different impact points when it is required for the model. Now, This might seem like a lazy approach, but it happens really often. You see, we cannot define everything in math. Even in math, when you define things, eventually you'll either run into a loop of defining things, or you will have the need to define something first without it containing a definition. Because these are the only two structures that can actually happen. Logically, there is no other way to do it. You always have to have something that defines the previous thing, unless that first thing is undefinable. That's how math was invented, and at some point we have to lose the definitions because we just cannot continue any further. At some point, we just have to... Maybe I'm just overthinking this. I mean, this is a bowl of soup, so...